Okay, we're continuing with part 2 of 11.2. We're moving on to problem 15 on page 748, and we're given a sub n to n over 3n plus 1, and the question is asking us determine whether part A, the sequence is convergent. Okay, so remember the limit as n approaches infinity from a sub n, in this case, by L'Hopital's rule, or just differentiating, if you remember L'Hopital's rule. If not, we can, let me show it. So limit as n approaches infinity from 2n over 3n plus 1. This is infinity over infinity. We apply L'Hopital's rule here. So then the limit as n approaches infinity. From pre-calculus, we know same degree over same degrees, leading coefficient over leading coefficient. But that's okay. So we differentiate this, we get 2. We differentiate this, we get 3. So the limit is 2/3. Because the limit exists, we say that the sequence is convergent. Because the limit exists. Since limit exists. In part B, however, we are asked to find whether, or determine whether the infinite sequence, the infinite series from n equals 1 through infinity from a sub n is convergent or not. Okay, but we see that the limit of a sub n as n approaches infinity is not 0. By the test of divergence, the infinite series is divergent. Okay, moving on. The next two examples are very important because they're dealing with telescopic series. Telescopic series. So let's take a look. Let's start with 17 on page 748, in which we have the infinite series from n equals 1 through infinity, of course, from 1 over n plus 2 minus 1 over n. So the question here is, determine whether the series is convergent. Is it convergent or divergent? And then if it is convergent, find the sum. So first part, is it convergent or not? Second part, if it is convergent, find the sum. Okay, so remember we have to look at the finite situation, which is the sum from I equals 1 through n from 1 over I plus 2 minus 1 over I. We will look at several terms of this infinite finite series in this case, and see what happens and if we can determine what it's called the a sub n. Okay, so let's take a look. We're going to start with I equals 1, and we get 1/3 minus 1 plus 1/4 minus 1/2 plus 1/5 minus 1/3 plus 1/6 minus 1/4 plus 1/7 minus 1/5 plus dot 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 plus. Careful now. I would like us to look at terms with, I'm going to write them here, but they're not part of this. I'm just going to make sure. Maybe I should write them on in a different spot. So I'm looking at n minus 5, n minus 4, n minus 3, n minus 2, n minus 1, and then n. And let's see what we get. So when we get to I being n minus 5 will be 1 over n minus 5 plus 2 will be n minus 3 minus 1 over n minus 5 plus. We reached n minus 4. 1 over n minus 4 plus 2, 1 over n minus 2 minus 1 over n minus 4 plus n minus 3. 1 over n minus 1 minus 1 over n minus 3. n minus 2 now plus 1 over n minus 1 over n minus 2 plus, because I'm crashing with this here, I'm going to continue underneath. This was n minus 2. Now I'm at n minus 1. So this is 1 over n plus 1 minus 1 over n minus 1. And finally, plus 1 over n plus 2 minus 1 over n, because it's from I equals 1 through n. We stop. Now let's take a look carefully and see what goes away. Okay, so we see the 1/3 with a negative 1/3 will go away. The 1/4 with a negative 1/4 will go away. The 1/5 with a negative 1/5. I anticipate this will go away. This will go away. What else? So let's see here. This will go away. This will go away. This will go away. Yes, these are going away with previous terms, and this one with this one. And what is left? Let's see. A negative 1 is left. A negative 1/2 is left. And what else? A 1 over n plus 1 and plus over 1 over n plus 2. Okay, now this is our a sub n. Now let's look at the limit as n approaches infinity from negative 3/2 plus 1 over n plus 1 plus 1 over n plus 2. And obviously when n approaches infinity, this approaches 0, this approaches 0. So this is negative 3/2. So what is our conclusion? So the sum from n equals 1 through infinity, from 1 over n plus 2 minus 1 over n, is the limit as n approaches infinity. From all this, negative 3/2 plus 1 over n plus 1. Oh, sorry about that. Plus 1 over n plus 2, which is negative 3/2. And this is the sum. Okay, so our conclusion is that the infinite series is convergent and its sum is negative 3/2. Okay, let's continue with another problem. So make sure that this is clear here. Good. Moving on, at page 7. Okay, so let's take a look at 19 on the same page, 748. Same idea, just an extra step here. N equals 1 to infinity, 3 n plus 3. Okay, so the same question. If determine whether the series is convergent or divergent, and if it is convergent, find its sum. Okay, so obviously in this situation we see the partial fraction decomposition is necessary. 3 over n plus 3 equals a over n plus b over n plus 3, which, as we know from our previous chapter 7, we get a with n plus 3, and we get b with n. Because the least common denominator, we have to multiply this by n plus 3, and of course this by n. Good, so we make n equals 0. If n is 0, then 3 equals 8. a times 3, so then a equals 1. And we make n equals -3. This disappears. 3 equals -3b, so this b equals -1. So then we can decompose n equals 1 to infinity into 1 over n minus 1 over n plus 3. Yes, we will look at the finite situation. The sum from I equals 1 through n from 1 over I minus 1 over I plus 3. And again, like we just went through this process a minute ago, we're going to do the same thing and then see what happens and get the sum of the nth partial sum and then continue from there. So let's see what we get. When I is 1, we have 1 minus 1/4 plus 1/2 minus 1/5 plus 1/3 minus 1/6 plus 1/4 minus 1/7 plus 1/5 minus 1/8 plus 1/6 minus 1/9 plus ... plus. So again, I'm trying to see as many terms as possible. So we're going to look at, again, n minus 5, n minus 4, and so on and so forth. So with n minus 5, we have 1 over n minus 5 minus 1 over n minus 5 plus 3, which is I minus n minus 2. Okay, plus. Now with n minus 4, 1 over n minus 4 minus 1 over n minus 1 plus 1 over n minus 3 minus 1 over n plus 1 over n minus 2 minus 1 over n plus 1 plus. Moving on to the next page, and this is page 8, plus. Okay. 1 over n minus 1 minus 1 over n plus 2 plus 1 over n minus 1 over n plus 3. Okay, and we stop there. And now let's see, hopefully a lot of terms go away. And let's take a look. So, negative 1/4 with positive 1/4, negative 1/5 with positive 1/5. What else is going away? 1 over 9th will eventually go away. 1 over 8th will eventually go away. Let's see from the last terms. So they will go away. They will go away. What else? These will go away. We anticipate that these also will go away with previous terms. Negative 1 over n plus 1 will stay, and this will stay, and this will stay. Yes. So we have 1 plus 1/2 plus 1/3 minus 1 over n plus 1 minus 1 over n plus 2 minus 1 over n plus 3, and this is, of course, the partial sum. Now let's determine the limit. The limit of s sub n as n approaches infinity is indeed the limit from I equals 1 through n, from ai, from n when n approaches infinity, which is the limit as n approaches infinity from all this. These three terms obviously will go to 0, so we only have this. I'm going to write it one more time. 1 plus 1/2 plus 1/3 minus 1 over n plus 1 minus 1 over n plus 2 minus 1 over n plus 3. And the answer will be, so the least common denominator is 6, a 6, a 3, and a 2. So that's 11 divided by 6. So that is the sum of the infinite sequence, the infinite series, I'm sorry, the infinite series, and that's the sum, and obviously it is convergent. Okay, so the next item on the list is geometric series. So the geometric series, infinite series, of course, from n equals 1 to infinity, AR to n minus 1. What does this look like? Oh, well, it's when n is 1, I have A plus A times R plus A times R squared, and so on and so forth, where R is the common ratio. How do I determine the common ratio? Simply by dividing any of the two terms, this over this, or this over this. So that's the common ratio. So the nth partial sum, it can be determined. It's a 1 minus r to the nth power divided by 1 minus r. And please remember the geometric series is convergent only for the absolute value, the common ratio being in the absolute value can be negative or positive, is less than 1. Every time r is greater than or equal to 1, geometric series diverges. So please remember that. Now, this is the nth partial sum. What would be the sum of the geometric series, assuming it's convergent when its ratio is a small number between -1 and 1? So the sum of the infinite series will be the limit of this, right? So the limit of a 1 minus r to n over 1 minus r when n approaches infinity. And this term, because r is a small number between -1 and 1, this term will approach 0. So the sum of the infinite series, geometric infinite series, is a over 1 minus r. Again, assuming that r in absolute value is less than 1. In any other situation, the series diverges. Okay, so now let's look at a few examples. How are we on time? Oh, okay, we have to stop. We'll continue with video 3.